In this video, we're looking at applications of angles. So we're going to start off with arc length and area of a sector. So an arc length is the length along the edge of a circle that has been created by an angle theta. So if we want to know the length of that, well, we start off with the idea that all the way around the circle, the circumference is 2 pi r. So if we're just taking a little section of that, a little fraction, some little angle theta, we're just taking a little piece of the full circumference, 2 pi r. And so we have a formula for the arc length. S is just a piece of the full circumference. And that's if our angle is in degrees. And then a piece of the whole thing, since 2 pi gets us all the way around the circle, the fraction describing that little piece of, with the arc length would be theta in radians over 2 pi. Now, because this can simplify just a little bit if we are dealing with radians, we've got 2 pi in the denominator, 2 pi in the numerator. And so this just ends up being theta times r if our angle is in radians. Okay, but it still just goes back to that idea that we're just taking a little piece of the full circumference, 2 pi r. All right, so let's look at an example. Find the length of an arc of a circle with radius 4 meters, subtended, that just means formed, by a central angle of 0.5 radians. All right, a radian, let's see, half a radian might be somewhere like around in there, 0.5 radians. All right, so our angle is in radians and our formula is S equals R theta. S equals R theta. Okay, so I want to know the length of S. My radius is 4 meters, and my angle theta is 0.5 radians, and so this would give me 2. That is a length of an arc, and so that is, the units there are meters. All right, let's look at the area of a sector. So the area of an entire circle is pi r squared. And if we're just looking at a little piece created by that angle theta, just a fraction of the whole thing. If our angle is theta, theta over 360 describes the piece of the full thing, and so then we can multiply that by the total area, pi r squared. So that's our formula if we're in degrees. Area equals theta over 360 times pi r squared. Now if our angle is in radians, oh, there's a little typo, that should say radians, then theta over 2 pi describes the little fractional piece, and then that just simplifies a tiny bit because our pi's can cancel. We have theta over 2, which is the same thing as 1 theta over 2, or 1/2 theta times r squared. Okay, so our formula, if we are in radians, is given by area is 1/2 theta times r squared. That's the area of a segment. So let's do this example. Find the area of a sector of a circle with a radius of r. R equals 9, and the central angle theta is 60 degrees. All right, so we have got degrees. We're going to do theta, just the little fraction of the whole thing, times pi r squared. Now our angle is 60 degrees. Okay, so that is our little section, 60 over 360, and then that's getting multiplied by what the area of the entire circle would be, which is pi r squared. R is 9. 60 divided by 360 is 1/6. Pi, and then 9 squared is 81. So this is 81 pi over 6, and then 81 over 6 let's see, both of those can simplify a little bit. We could at least divide by 3. So we would get 27 pi over 2. Now area, that is square units. And then if we wanted an approximation, we could just plug in approximation of 3.14 for pi times 27 and divide all that by 2, and we would get approximately 42.4 square units. Another application of angles is linear and angular velocity. The angular velocity is the idea of how much the rotation theta is changing over time, and we use the Greek letter omega that looks like a W for angular velocity. Okay, so that's given by the theta, the angle changing over time, theta over t. Now linear velocity, that would be like the edge along the edge of the wheel, how much that's traveling along the circumference there. So that arc length, how the arc length is changing over time. Okay, so that is our linear velocity. So my example is a saw uses a circular blade with 6 inches diameter that spins at 3,580 RPM, revolutions per minute. And the question is, how quickly are the saw teeth moving in miles per hour? Right, so we're looking at one little sawtooth, like for example right here, and we want to know how fast is that going in miles per hour. So let's see, the diameter is 6. So that means that the radius is half of that. The radius is 3. And the circumference of a circle is 2 pi r. So that's 2 pi times 3, or 6 pi. Now, when I make one rotation, my little saw tooth goes around one full circumference, okay? So the big idea, or something that's really going to help us with these problems, is that one rotation, or let's see, we're talking about revolution. So one revolution gets us the same as one circumference. That's going to be helpful on all of these problems. All right, so what I'm going to do, the process is I take what's given to me. So in this case, it's given that I'm going 3,580 revolutions per minute. I'm going to write that as a stacked fraction here, and I'll kind of show you why that's helpful. Okay, so I write down what's given. Write it down. We got that. Write that down. Okay, now I am going to just do some unit conversions. I want to know what that is in miles per hour. Okay, so we're going to take and multiply by a whole bunch of unit fractions. Okay, one revolution is the same as one circumference. Okay, so I want to cancel out revolutions. So I'm going to put revolutions down here so they cancel. One revolution is the same thing as one circumference. And I have 6 pi, and that, I should have written that down. That was in inches. My circumference is 6 pi inches. Okay, so that's helped us go from revolutions to inches, but I don't want inches, I want miles. So I need to convert from inches to feet. 12 inches is 1 feet. So my inches cancel. I don't want feet. So I want those to cancel. So I'm going to put feet on the bottom. What I want is miles. So 1 mile is the same thing as 5,280 feet. All right, so now I have written out all those unit conversions I need to go from revolutions to miles. And now I don't want minutes, but instead I want hours. Okay, so I don't want minutes. Use the fact that 60 minutes is the same thing as 1 hour. Okay, and then my minutes will cancel as well. And now what I do is I just figure out all the things in the numerator position. Let's see, I have 3,580. I have 6 pi. Nope, that should be 5,000. I have 6 pi. I have 60. Everything, all my units canceled except miles. So that's all the stuff I'm going to write in my numerator. So 3,580 times 6 pi times 60, and the units in the numerator are miles. And I'll just plug that into my calculator. And then I'm going to look at everything in the denominator. Let's see, the only thing I have down there is I have a 12, I have a 5,280, and my units there are hours. Okay, so in the denominator, I'm going to write a 12 times 5,280, and the units down there are hours. Okay, and then just pull out your calculator, multiply everything in the numerator and get an answer, multiply everything in the denominator and get a number on that, and then divide the numerator divided by the denominator, and you should get about 63.9 miles per hour. Pretty fast. I would not want to get hit by that sawtooth. All right, so again, just to recap, what you do is you take what is given and just write it down. That RPM we're going to write as a stacked, those units, just write them as a fraction with what's in the numerator, what's in the denominator. The revolutions is first, so that goes in the numerator, and then the per means divided by the minutes goes in the denominator. Okay, and then these problems are just unit conversions. Okay, let's do another one. Okay, a truck with 26-inch diameter wheels is traveling at 45 miles per hour. Okay, I'm going to take what's given to me and write it down. 45 miles per hour. Okay, so I'm going to write that miles per hour as that with miles in the numerator, hours in the denominator. Now the question is, how many revolutions per minute will the wheels make? All right, so what I'm doing basically is just converting miles per hour to revolutions per minute. Okay, so my units that I want eventually to get are going to be revolutions per minute. Okay, so I don't want hours. I want hours to cancel. That means that my unit fraction here needs to have 1 hour in the numerator. That's the same thing as 60 minutes. Now I don't want miles. I want revolutions. Well, let's do a little picture here. Okay, our wheel is 26 inches in diameter. That means the radius is 13 inches. And the circumference is 2 pi r, which is 2 times pi times 13. That is 26 pi inches. All right, so 1 revolution means that we're going to go 1 full circumference. Okay, so we can use the fact that 1 revolution gets us 26 pi inches, or 1 full rotation, right? That's the little speck on the edge of the wheel, and it's going all the way around 26 pi inches in 1 rotation. All right, but our units were given in miles, so we don't want miles. We'll use 5,280 feet is in 1 mile, but since our circumference is in inches, we want to convert. So we converted from miles to feet. We don't want feet, so we'll do that. 1 foot is 12 inches. So now our feet cancel. Okay, good. And now I can use the fact that, this isn't quite big enough, Okay, I'm almost done. Okay, so I can use the fact that 26 pi inches, that's the circumference, is 1 revolution. Okay, yay. So look at what we've got. We have in the numerator, we have 45, 5,280, 12, and the units in the numerator, everything canceled out except revolutions. Okay, in the denominator, I've got 60, all the units canceled except minutes, and I've got 26 pi. So now I'm just going to write all that, just kind of simplify that a little bit. Okay, in the numerator, I have 45 times 5,280 times 12. The units there are revolutions. In the denominator, I have 60 times 26 pi, and then the units there are minutes. Pull out your calculator, take all the numbers in the numerator, multiply them all out, get some big giant number, and divide by everything you have in the denominator. Okay, and we should get about 581.8 revolutions per minute.